8.3, connecting fractions to division. Okay, this time we're not gonna explain the lesson. I'm gonna help you do your homework. Okay, so these are examples that are similar to your homework questions, and I'm gonna teach you how to solve them. Okay. Okay, for the first question, I have a 4 divided by 6. Okay, now we already talked about how the division sign, this division sign, okay, is equivalent to the fraction bar. This fraction line is equivalent to the division sign. They mean the same thing. They both mean that we are dividing. Okay, now for this number here, I have a 4. Okay, this 4 goes to the denominator above. Okay, and this 6 goes to the denominator below. Okay, so instead of writing it as 4 divided by 6, I can write it as 4 over 6, and it is going to mean the same thing. Okay, now you have to ask yourself, should I stop here? Is this the simplest form for the fraction, 4 over 6? You gotta ask yourself, where do 4 and 6 meet in a timetable? Which timetable has 4 and 6 in them as a product? Okay, let's try timetable 2. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have, so I know that 4 and 6 are in timetable 2. Okay, that means that I can use the do-do rule to divide by 2 up and below and give myself a 2 over 3. Now, is this the simplest form? Yes, because the difference between the number above and below is only 1. Okay, so it's impossible that they can be divided by the same number. Okay, now for this example, we have a 3 divided by 12. Okay? Fraction bar. Okay, this number goes to the denominator, the one before the division sign, and the one after the division sign goes in the denominator. So we have 3 over 12. Okay, is this the simplest form? No, it's not. Okay, where do 3 and 12 meet in a timetable? Timetable 3. So if I divide by 3 up and below using the do-do rule, I get a 1 over 4. Okay, now for this question, we have a 5 divided by 4. Fraction bar. The number before the division sign is above, and the number after the division sign is below. So I have a 5 over 4. Okay, is this the simplest form? Yes, but for an improper fraction, this is an improper fraction. Now, can anyone help me recall what improper fraction is? Improper fraction means that the numerator is bigger than the denominator. So I'm gonna have to turn this number into a mixed number. How do I do that? I gotta think, is 5 divisible by 4? No, it's not. Okay, what is the number that is less than 5 that is divisible by 4? Is 4 divisible by 4? So if I take 1 away from the 5, I get a 4. Is 4 divisible by 4? Yes, it is. So I can split this fraction into 2 numbers. 4 over 4, and the other one is 1 over 4. If I sum them up again, we have like denominators, so I can sum them up again. If I sum them up again, they're gonna amount up to 5 over 4. So I split them into 4 over 4 and 1 over 4. Okay, what does 4 over 4 get me? What is any number divided by itself? It's 1. So I have a 1 and a 1 over 4. Okay, now for this question, we have an 8 divided by 3. So if I want to turn this problem to a fraction argument, I'm gonna have to put the 8 above and the 3 below. Now it is still an improper fraction, so I'm going to have to switch this number to a mixed number. So I have an 8 over 3. Is 8 divisible by 3? No, it's not. So is 7 divisible by 3? No, it's not. So is 6 divisible by 3? Yes, it is. So I'm gonna take a 6 over 3 out of this 8 over 3, and what do I have left? I have a 2 over 3. Okay, so what's a 6 over 3? What's a 6 divided by 3? It's 2. 6 over 3 is 2. And what about the 2 over 3? It goes just as it is. So I got a 2 and 2/3. This is 8.3, connecting fractions to division, and these are examples to help you solve your homework.